The following presentation was recorded at the third NDS Public Conference in June 2021.
This part of the NDS Public Conference today is about the presentation and demonstration of the achievements of NDS Live, of the Joint Development Team. And this is a collaborative effort of several NDS member companies, and Fabien Clebert will guide you through this part, including an overview of NDS Live. So Fabian, the stage is yours.
Thank you. All right, so yeah, then let's start right away. So hello, everyone. I'm Fabien Klebert, the technical coordinator of the NDS Association, and today I'd like to welcome you together with my fellow speakers from the NDS Live Development Team. So within the next 90 minutes, we'll give you an overview what is currently going on with NDS Live and how the NDS members are using the next generation map standard. So, but before we do this, let me quickly introduce you to the other speakers. So today with me are Dirk Spieswinkel from Elektrobit. He will talk about their ADASIS solution and how EB connected this to the NDS Live services from here, Navinfo and TomTom. Then Michael Westphal from Harman. They just recently joined the dev team, so he will talk about what their contribution will be in the near future. Also with me is Boris Gumhold from here. He will talk about the NDS Live services from here and how they build a NDS Live data service for ISA, the Intelligent Speed Assist. Frank Aurich from Joynext will demonstrate their implementation of the NDS Live routing service. Nico Glorious from Navinfo will talk about their smart layer services for map data and speed limits, including dynamic speed limits. Otto Nero from NNG will demonstrate how smart layer path and horizon assist services can help to reduce the data bandwidth and how to get the most out of the new possibilities of the what basically NDS Live offers now. And last but not least, Christian Schneider-Wieland from TomTom will show how they quickly ramped up their services after joining the dev team only 2 months ago and what they will do in the future. So, but before we do that, so in case you haven't followed any of the recent webinars that Martin already referred to in the beginning, if you haven't joined those and already know what's going on, I'll try to summarize the most important facts about NDS Live. So you may have seen this, we say it all the time, NDS Live is not a database, it's a distributed map data system. So I have to say this again today. The idea is that NDS Live is the one language of map data for the whole ecosystem, right? So whether it's B2B or B2C, whether it's from cloud to car or within the car, the map data doesn't need to be transformed into any other formats any longer. That's the basic idea. So when we say we want to cover all these parts of the data throughout the ecosystem, we have to answer a couple of questions. And one being the most prominent one and most important one, is a physical storage format sufficient for this? Long story short, no. So what is so instead of simply being a physical storage format, NDS Live defines service interfaces now, in contrast to NDS Classic. So the map data encoding is still at the heart of NDS Live, right? So it's still about all the data encoding, but the encoded data is now also shipped in addition via standardized service interfaces, and it is packed into flexible data layers in predefined data containers. We'll talk about those in a second. So the key takeaway here is that NDS Live is not standardizing an on-disk format any longer as we did in NDS Classic, but it's now service interfaces plus the data encoding. The smart layer concept that has been introduced is enabling people to scale along the needs of the industry, right? Map services can now more easily than ever scale along the car lines like you see here, or the functionality without the need to maintain different compiler branches and delivery pipelines. So the idea is simple, you stack together data layers and you keep adding more for increased functionality. So, and if done right, this solves a lot of headaches that you usually have to bear with when you're compiling map data for a variety of consumers, right? Because different consumers usually all have their tiny little differences when it comes to how they need their data served. So think about it like you're running a restaurant for a variety of customers, right? So you do want to have standards as much as you can, but still you want to serve individual experiences to your guests, right? So you still want to make some money. So there's no time to cook everything from scratch. So you want to mix and match the standards with the ones that you can see. So you can see here, for instance, in this example, everyone has the red and blue slices in the smart layer. So they're basically the road and the speed limits layers. And some other cars, they have simply more, for instance, lane geometries as well, or additional ADAS attributes. So the smart layer data comes in containers. So, and these are three different ones that we have in NDS Live. It's tiles, it's paths, and it's objects. And these data containers, they differ in the spatial extent that they're covering. So map tiles are simply tiles that follow a predefined tiling schema. Paths are paths along a road. So basically all the data along a stretch of road, which can also include, which basically includes the road itself plus some stubs around or even longer. So that is quite configurable. You will see this in the presentation of the Smart Layer Path services by NNG later in this 90 minutes. Objects, they don't have any predefined spatial extent, right? So a good example would be an indoor venue or a parking garage or something like this. And then there is still some data in NDS Live that will not fit into any of those predefined containers. So especially the data that's coming from application services. And these are then additionally defined besides the heavy lifting smart layers. Yeah, on an earlier slide, you remember there was like this little NDS Live icon on every communication channel available. So I told you then that we went from physical storage format directly to service interface. So that basically leads to the question, which transfer protocol to use for these services? So the answer is NDS doesn't standardize this. So the reasons are simple. There are many suitable protocols around. Defining a standard that includes all of them is not really feasible. And to make a bet on a specific one, even if it's the most commonly used today, is still a bet, right? So especially when you take a look on transport protocols inside cars, you simply need to be able to run on top of any custom protocol. That is why we designed NDS Live not to rely on a certain transport protocol. But we also acknowledge that leaving out this answer is not helping much sometimes when you're developing an NDS Live based system. So what we have done here is we have introduced a layer in between the transport layer and the NDS Live service layer. We call this the reference layer, where we actually choose commonly used transport protocols like HTTP REST and provide reference implementations for those, plus some kind of extra specification, what to use out of them and how to fill things and how to deal with the freedom that it gives you. So we'll see that in the next slide. But before we go, let's remember the NDS Live runs over any cloud protocol as well as over any in-car protocol. So let's take a quick look on the architecture. So let's go through that from top to bottom, quite straightforward. So NDS Live defines the data encoding in separate modules. For example, a lane module, a road module, rules, driving rules module, and so on. And then they get all served via the NDS Live service layer, right? And that reference layer, which sits below that, actually translates these services then into other common service documentation standards, like, for example, the Open API spec for HTTP REST. And then the implementation basically plugs in any desired transfer protocol underneath. So this is how this works. And yeah, that was a real quick rush through the concepts of NDS Live. We have a lot to show you in these 90 minutes, so that's why I'm trying to keep it short. So if you're interested in more details, go check out the recordings from our NDS Live webinars. They are all available on the NDS YouTube channel, and they include more details and some examples on how to use NDS Live. So go check out these recordings for more details. Yeah, but we said we're going to talk about the development team that is with me today, but before we do that, let's quickly also turn to the available tools. In the NDS Association basically supports the development of services and client application by a dedicated tool, which is called Live Lab. That includes a map viewer and IDE to help the customers or the users actually to connect to NDS Live services, to inspect them and visualize the NDS Live data. So Kadim earlier referred to the database inspector, which was the database inspection tool for NDS Classic. Live Lab is basically the database inspector for NDS Live. So we got a map viewer and additional IE and inspection tool. And then in addition, the developer portal we have built up, so that is carrying not only the documentation, but is also a growing source of tutorials and best practices. And reference implementations and sample maps give NDS members a jump start and help speed up their own developments. And this is what is the offering in terms of tools. So the development team. The NDS Live development team is basically, let me quickly explain what it is. It is a group that is open to all NDS members. It provides a platform to develop interoperable solution towards the first commercial NDS Live products. So with having a highly connected developer community basically, the members ultimately push forward the further development of NDS Live. So it's not done only on paper, but by implementing proof of concepts, but also going beyond that and connecting NDS Live solutions also directly to their existing software stacks. But people will tell you in a minute about it. So at the moment, let's take a quick look on who we have there. So at the moment, we have here Navinfo, TomTom, NNG, and Joynext providing data and application services. So they all share access to these services among each other so that the interoperability can be tested. So as well as we're sharing other findings here. And then Elektrobit, Harman, Joynext, and NNG are working on client applications that consume the data of the services. So we will mainly see those applications in the upcoming demos now. Yeah, having said that, I would like to hand over to Michael Westphal from Harman for the next presentation on how Harman will contribute to the NDS Live development in the future. Michael.
Thank you, Fabian. So, yeah, I want to talk about the efforts regarding NDS Live inside our company. And yeah, perhaps at first some recapture of the situation regarding NDS and the importance of NDS for Harman. So Harman is a founding member of the NDS EV and represented on all relevant committee levels. We offer a rich, mature portfolio of NDS Classic-based premium infotainment solutions on supporting broader diagnostic global coverage. And this was proven inside dozens of successful customer projects already. And the NDS Classic Foundation enabled us to seamlessly connect premium embedded and mobile client SDK with scalable cloud SDK services. And regarding these cloud services, this is our intention to use NDS Live now because NDS Live allows us to utilize an interoperable and standardized format for a microservice-based cloud solution. Therefore, Harman is really highly motivated to actively support as part of the NDS Live Joint Development Team now. We joined last month, and in order to contribute to another chapter of the NDS success story, because we are convinced that we can repeat the success of the NDS Classic with NDS Live. Yeah, so perhaps you're asking why we are focusing on Java. So some historical reasons are that we have a broad foundation of NDS Classic database compiler frameworks and compiled maps, and these are based on Java technology stack. And we would like to use the know-how, of course, and what is already present for us. So NDS Classic and NDS Live coexist in synergy. So this means we utilize already some of our NDS Classic databases as data input paths for our cloud services. And now we are transforming these cloud services to NDS Live. And this is the reason now we are focusing on the Java part. So if you think about use cases, not only B2C, but B2B services, for example, as a kind of proxy, taking data from several data providers or service providers and yeah, sending it to an end customer, to the car at the end. And common cloud services allow more freedom than restricted embedded target devices because of the capacity, performance, and memory, whatever. Therefore, Java can be a good selection there as well. So we don't want to limit the usage of a technology stack, and therefore we want to improve the Java technology stack regarding NDS Live. And because of this, we want to support the NDS Live development with our expertise by contributing the Java infrastructure support for this framework or this technology. So what was the situation regarding NDS Live till March this year? So we have this serial code generation. It's, for example, used by the NDS package manager, and it can generate code for C++, Java, and Python. Then we have some reference REST server and client implementations. On the one hand, the common serial implementations available for all people and provided on the GitHub in the Zero project, but they are especially for the HTTP REST variants, we only had the Python part. So for C++ and Java, there were different transport protocols, as already told by Fabian. And yeah, this was the situation regarding that. And additionally, in the meantime, Fabian's team started to implement some OpenAPI support, but this project is providing only C++ and Python. So that was the situation. Perhaps Fabian, please, yeah. Perhaps some history regarding our efforts so far. So we started with the reference REST server and client, and already published this in the common Zero GitHub repository. Now we have some Zero service example done in Java for the HTTP REST services. And yeah, you can use it with the Python example. So you can use the Python server with the new Java client and vice versa. So they are compatible and showing already the interoperability of these implementations. And what we are currently working on is the OpenAPI based generic interoperable REST client implementation. This means that from a server implementation and OpenAPI description is generated automatically, and then you can either hand it over to people who want to build a client, or in the same time, now the Java client is generated on the fly. So this is what we are currently working on, and this is continued currently in the NDS Live Joint Dev Team. So perhaps a really short overview, what were the requirements when we are choosing the technology stack? So at first it should be modular. This means we should have as less as possible dependencies. It should be easy to deploy and use well-known common approaches. As already said, we want to use REST-based services using HTTP as a communication layer. And in common, the framework and tools should have active development. They should be robust, reliable. The license should be permissive. There should be available much documentation and a really big developer community. And therefore, we selected Apache Maven as an infrastructure tool, because you know, perhaps if you're doing some Java development, you have this Maven Central point where you can download and access libraries, external libraries. And for the application stack, we are using Spring Boot as a basis, which is very reliable and very widely used, not only for microservice, but for Java application in common. And on top, for the communication, we have chosen the modern approach of the Spring framework, which is the Spring Web Reactive, which is dedicated really to use massive number of concurrent connections, therefore ideal candidate for our cloud services. So in contrast to the Spring Web, where we have a synchronous blocking IO architecture and one request per thread model. So perhaps this should be enough regarding the details. Yeah, and this should conclude my presentation. Thank you.
Good, thank you. And so we'll continue with Boris Gumholdt from here.
Hey, Fabian. Hey, this is Philip. I'll provide a quick introduction.
Okay, you'll do that, Philip. Sorry.
No worries. So my name is Philip Hubertus. I'm a product manager for automated driving content at here. And as I said, together with Boris Gumpold, senior manager engineering at here and NDS Association technical chairman, we're going to provide context and the technical details of the NDS Live Map service by here. We believe the market needs can be clustered into 3 segments. At the entry level, map data is needed to enable ISA and basic ADAS features. In the mid-range, the map data needs are becoming more detailed to enable more advanced driver assistance systems, often in combination with a premium IVI navigation experience. And at the high end, we see vehicles requiring a combination of map data to support ADAS, IVI, and automated driving use cases. Now, NDS Live is defined to allow an independent yet aligned publication of map content layers, and these can be stacked nicely, and that is what we're building at here. We're leveraging our already existing productized NDS publications, the here ISA map for intelligent speed assistance solutions when vehicles are not equipped with ADAS or navigation, the here ADAS map, which is a comprehensive here content bundle for ADAS and electronic horizon solutions, the here navigation map that covers the needs of premium IVI use cases, and the here HD Live Map that caters to the needs of automated driving. The data layers are fed by our map content management systems, and it takes all the content we source from third parties, data from our own here true drives, an increasingly growing pool of sensor data and probe data that all feed into our map applications. We highly automated these pipelines so that the real-world changes are published as map updates much faster. NDS Live Map services from here give you the advantage of getting the needed map data straight from the source. And all this translates to the following advantages. There's a cost advantage because there's no need for large storage hardware in the vehicle and downloading large update regions like the whole of Europe or multiple countries. Vehicles will only consume the layers and coverage they really need. Then you get a great user experience that's hassle-free because there's no need to trigger an update or to download something to a USB stick. It's future-proof and caters to the expectations of digitally connected consumers today. And NDS Live enables scale or stacking to add more features later, reconfiguring features of a vehicle on the showroom floor if that's needed or for the used car market. And there's no need to consume the same data twice because different features needed. And now I hand over the virtual stage to Boris for the technical part.
Thank you, Philip. Yeah, I will present a technical solution for delivery of here NDS Live and NDS Live Map. Our technical solution is, of course, based on the here platform, where we provide and publish our map content, and that includes also fetching and processing sensor data from the vehicles. Within our platform, we are going to consume that internal map content and convert it into NDS Live map data and publish it internally. And then we will make it available to outside world through the NDS Live services, so registry service and smart layer service. Within the platform, of course, we also provide authentication solution that's simply necessary in order to communicate or send the data to vehicles. We need to interact with car manufacturer's cloud and then perform authentication. Vehicles will access our services via NDS Live interface as defined by the format itself, and then they can run their own applications, for example, electronic horizon, etc. And of course, then because they will access our NDS Live, specifically NDS Live ISA map. So in this case, they will mostly interact with our service by downloading tiles or groups of tiles. We also provide option to download, I say it a bit carefully, to download groups of tiles in the so-called offline mode. That means a vehicle can download, let's say, group of tiles and these live tiles while connected on Wi-Fi. that we provide because some car manufacturers have some legal restrictions in some countries or some other technical business reasons why their vehicles cannot always be online and connect to the NDS Live service while driving. The publishing cycle of our map can vary. It depends on the NDS Live layer type. For example, daily speed limits, which we can publish daily, and then some other data like ADAS attributes we can publish monthly. It's actually very configurable and adjustable to specific use cases. So unlike with NDS Classic, NDS Live provides this flexibility. So from the business point of view, it's much more attractive and feasible to host and serve NDS Live data. Of course, validation within our HERE platform, we do intensely validate the data using our internal HERE validation approach, but also we are actually working currently on applying or using NDS Live validation. And for that, we are actively working within NDS Consortium on developing concepts and supporting the people who are implementing those solutions. And hopefully somewhere in Q3, we will have some first result for that. Okay, that would be like really in a nutshell and very high level description of how HERE is providing NDS Live ISA map using NDS Live Map service. Thank you. Who is next?
Okay, so thanks. So next is Nico Glorious from Navinfo.
Thank you. I'm Nico Glorious from Navinfo, product manager for data delivery systems and services within Navinfo Europe. And first of all, I'd like to quickly recap how we as Navinfo have started our development within the NDS Live Joint Development Team. So next to our current NDS Classic-based services with global coverage, up to monthly map updates, daily updates of specific map layers, and incremental updates, we started to support the development of NDS Live, focusing on ADAS and HD maps in order to extend our current offering by a streaming solution for the high detailed and frequently updated map data that is required for advanced driver assistance systems and highly automated driving. So after the initial versions of the specification have been published for development purposes, our first step has been to implement an NDS Live tile-based streaming service for HD lane data, which we've already presented during the last NDS Public Conference and which is available to our partners and customers since then. In order to make our offering complete, we continued with the implementation of additional modules that are required to model the road network with all its attributes, meaning road, characteristic, rules, and the ADAS module. And having this available now as the basis for NDS Live tile-based streaming services, we've also implemented such a service based on OpenStreetMap data and the dedicated service that focuses on providing a solution for the ISA regulation of the European Union. Last time we've talked about the NDS Live service for HD data, and today I'd like to focus on the additional parts that make the service complete for ADAS and HD use cases. The layers of the road module itself describe the road network with connections between intersections and also the geometry of these links. But in order to have meaningful information about the road network, you also need additional layers that describe the characteristics of individual road segments, of intersections and transitions. And for that, we have the characteristics module, the rural module, and the ADAS module. In the layers of the characteristics module, basic characteristics of the road, lanes, and intersections are described. These are attributes like functional road class, road and lane type, average speed, pavement, and so on. And using layers of the rules module, you can describe different types of rules that apply to roads, transitions, and so on, for example, speed limits, turn and travel restrictions, overtaking restrictions, but also such general rules like legal requirements to carry first aid kits within your car. Last but not least, we have the ADAS module, and in these layers you can provide detailed attributes that are required for ADAS systems, and these are typically slope and curvature, but can also be a comfortable driving speed for curbs. Having this all implemented now, we have the basis to provide various services for different use cases with flexible layer configurations specific to and optimized for a certain use case that can be based on different data providers, and that will be provided through a standardized interface with a unified and interoperable global fitting. Based on this NDS Live tile streaming framework, we've also implemented a service using OpenStreetMap data. We've implemented road network, simple characteristics layers with road class, for example, a simple rules layer with speed limits, and an ADAS layer which contains curvature and slope information. This proof of concept has been made available to all members of the NDS Live Joint Development Team and is used to evaluate the usage of OpenStreetMap data for various use cases with regards to coverage and quality. As the first commercial use case for NDS Live, we've implemented NDS Live type-based services for speed limits with dedicated layers optimized for the ISA use case. We've implemented both possible referencing mechanisms, which is direct and indirect references, and we've also created a service that integrates variable speed limits from an online service. As just mentioned, there are two different mechanisms to link attributes to features like links, lanes, and intersections, and the first one is direct referencing. This mechanism uses NDS.
Recording in progress.
This mechanism uses NDS feature IDs of a dedicated service and layer to reference on an attribute or group of attributes to a specific feature. And using this mechanism, you can create a seamless and integrated map, making it quite easy to use this combination of layers. On the other hand, if you want to provide a map layer independent of the underlying map, you can use indirect references. By using such a map agnostic layer, you can provide your service to multiple users or customers with different underlying maps or different versions of these maps with less effort on your side, and you can also reduce the complexity of map version handling. NDS Live itself provides some flexibility in how to create indirect references. Next to coordinates, you can also store additional attributes like bearing to the next segment, road class, road type, road number, and so on. This enables us to optimize the references and store as little information as possible, but as much information as needed to resolve ambiguous situation and make the references as accurate as possible. Next to static speed limits that are typically included in the map data, variable speed limits should be added to a speed limit service in order to increase reliability of ISA systems. First, the references to the map features must be created. Therefore, the gantries and variable speed limit signs must be identified and matched to the road network. Afterwards, you must identify the road segments for which the speed limit on these signs apply. Now, on highways, you typically have the situation that you have a gantry right before a highway exit, and the next gantry is located directly after the corresponding highway entry. In these cases, the speed limit from the first gantry needs to be applied to all highway links between the first and second gantry, but not to the links that follow the highway exit. And there are other ambiguous cases, and the rules that apply depend on legal regulations in the country, for example. Therefore, we've implemented country-specific rules and heuristics to solve that. After these basics have been implemented and set up, the actual speed limits can be retrieved from multiple online services. The actual values are assigned to the previously identified links using the gantry identifiers, and an updated NDS Live layer can be created and published to the customer. We have marked this NDS Live layer as using dynamic data, meaning that the layer is not versioned as it would be in case for static data, but there is a lifetime with an expiration time. As the provider for the variable speed limits that we are currently using publishes its data every minute, we are also publishing our speed limit layer every minute and have set the expiration time accordingly. The available online sources for various speed limits are not yet covering all countries and work classes, but we are adding more and more sources as they become available. So, as of today, we can offer NDS Live type-based streaming services using SD and HD data to support ADAS use cases, autonomous driving, and so on, but also more specific services to comply with the ISA regulations of the European Union. Using NDS Live, we can offer these services based on various sources with flexible configurations, but with a unified global filling. So that concludes my presentation, and I'd like to hand over to the colleagues of TomTom. Thank you.
Okay, thank you. So next up will be Christian from TomTom. But I think, Christian, you wanted to take over the presentation by yourself, right? So.
No.
Oh,
no.
Only after the, oh, sorry.
Only then,
after the
yeah.
demo for, okay.
Exactly.
Then let's go ahead.
Hi, everyone. Here's Christian Schneider-Wieland from TomTom. I'm product manager there for NDS data. And we share our presentation together with Uli Otto. You know him. He will make the technical part. If you would like to click once. Okay, thanks. TomTom is in NDS since the beginning, since a really long time. We have spent a large investment to adopt the NDS Classic for our own TomTom portfolio. And this was a real success story. So NDS Live is for us seen as the next generation of the standard. And that made us also the decision to join the proof of concept phase and the development team 2 months ago. And our main interest is, of course, to learn on technical feasibility and the complexity of the NDS Live spec and technical details and future market potentials of this. We want, with this proof of concept, to demonstrate interoperability, so several clients could access our TomTom services. And we are interested in the Java reference implementation as offered by Harman. And also there, the validation by multiple parties. So far, the scope of our TomTom basic NDS Live service is NDS Live Smart Layer Tile service with several layers and content filled, and the NDS Live registry. So next slide, please. So in the evaluation of NDS Live, which as said, we have joined 2 months ago, we ramped up a proof of concept with a limited amount of effort, several man-months, to get this up and running. We are having used the NDS Classic map as is standard from our TomTom offer, together with the access layer, and this together gave an easy head start. And TomTom's knowledge about cloud navigation contributed to that as well. The Live Lab, as offered by the NDS Consortium, was very helpful to test and debug, and we use it as a helpful framework for that. And our next steps in the coming weeks and months is to complete the road rules and the road characteristic layers. And of course, to work on the high freshness of base data, as this is in our genes, to look for high freshness data for navigation, ADAS, ISA, and so forth use cases. So first step is to enable weekly updates and going up in the frequency up to daily updates for all smart layers, which we are offering. Then with this, allowing to validate the versioning mechanism as defined in NDS Live, and to support on client side the different update strategies. And with this, I would like to hand over to Uli for the architecture part and a small demo. Thank you.
Okay, thank you, Christian. Can you hear me?
Yeah.
Okay, yeah. So this is just to explain what we have been done in the past 2 months. So we, as Christian mentioned, we started with an NDS Classic, our ADAS map that has certain layers defined, so track attributes, road geometry, and routing tiles. we implemented some adapters in order to translate these on the fly into the corresponding NDS Live tiles, so road feature, geometry, rules, and characteristics. And at the output side, we have an NDS Live smart layer tile service that is composing these different layers. And in addition, we also have implemented NDS Live Register service, which is important in order to actually discover what the service is using. The initial client was the NDS Live Lab, but later on, we also then, when the service was mature, we worked also with the other proof of concept partners. And our service is running in Azure cloud. So we have both. We have a staging and we have already a production service running there. And I would like to give you a very quick demo that you actually see that it's not difficult to start with NDS Live and that you can quickly set up something by yourself. For that, I'm going to share my screen. Let me see. Okay. Can you see something?
We see you only.
Okay.
Not yet.
That's good. So then I will now switch on the.
Now we can see it. Yeah.
Okay. Now you should be able to see.
Yep.
So okay. So what you can see here is the Live Lab tool. What I will going to do is I will first start the map viewer window. So that's the map viewer that you can see here. Yeah. Okay. And then in the next step, I will also just run a small test script. So if we then go to the viewer, what you can see here is, so this is the tool. So it's just the one who knows database inspector should be familiar with it. It's the map viewer part of it. And the small tool that I started was so that it's running on my computer. It was connecting our service in the Azure cloud, and it was downloading a single tile. So from the smart layer service. So what you can see here is it's just a tile. It has some links. You see attributes here from, for example, speed limits. It also has intersections so that you can see some of the attributes. Now the interesting part is I can click on the other tiles, and then the tool is downloading immediately more tiles from the service, so that you can see this is NDS Live is quick. It doesn't take a long time to download a tile, to unpack it and to render it. Yeah? So that you get an idea about this is in fact what an application would do when driving around. It would, while it's moving forward, it would download further tiles and would use them on the application side. And as you see, this is just a result of 2 months of work. So you can see that really with some knowledge, it's pretty straightforward. Start setting something up and actually using NDS Live. Okay, that's it for the demo side.
Thank you.
Okay,
That's
thanks.
all from TomTom.
So then next up would be Dirk from Elektrobit. Dirk, you wanted to share your own, right? So you are.
I would try to take over the control if possible. Otherwise, I can try to share the slide deck also from my side.
Okay, so I can show it and you can, so it depends how you want to do it.
Okay, let me just share.
Yeah.
Let's hope this works out.
Oh, wait a second. I can still share it and you can, but I'm not sure if the controlling works, and I'll just simply click it through then for you and while you're talking. Okay.
Well, let's try. Can you see my share?
Mm-hmm.
Okay, very well. Yeah, thank you everybody for having me here today My name is Dirk Spieswinkel. I'm product manager at Elektrobit. I'm responsible for our electronic horizon solution. And also we are looking into NDS.Live interoperability because we are on the client side. So far we have seen a lot of presentation from the service side on the backend, and we focus on the client side and try to get everything up and running with different backends, multiple service suppliers, and notice, okay, there's still some stuff to do on the client side. But in general, works out. Let me click through. So in general about map data, back in the days, everything was static within the vehicle on the ECU, and it maybe was updated with a cadence, in somehow getting shorter. So first once a year, then twice a year, now even often, but obviously, everybody is moving towards a server-based solution. And likewise, we also support it. So today, of course, you need up-to-date map data. I guess that's been highlighted in the previous presentations already. And of course, it should be either standard definition or HD, depending on the use cases to be supported, obviously. The setup with NDS.Live, as we see it from a client perspective, on the left side you can see the cloud with the NDS.Live information, as shown from our colleagues from TomTom here, Navinfo, etc. And someone needs to fetch it. That's the client part. But then it also needs to be distributed and enriched. And that's where we focus on another standard, ADASIS version 3, and to provide such kind of lane level information. So we have an electronic horizon provider providing the ADASIS version 3. So that's works very well in line with NDS.Live. And there's a map abstraction concept in place to make use of either standard or high definition maps. And on the enrichment side, of course, there can be additional data fused in and also propagated using ADASIS version 3. And it can be a scalable API or architecture to support multiple backends to the NDS.Live. So depending on what protocol is chosen really to get the data. And of course, then the map client implementation is only needed once, likewise the caching strategies as well. And of course, the backend architecture itself, it can be, and the map provision itself, it can be independent from how the data is fetched and how it's distributed. And I want to present you today our latest efforts on testing the interoperability. So we have a small demo setup on the right side. So we have the cloud with different backends. For today, we tested here Navinfo and the TomTom backend. And we use this information to fetch tiles along the car position, smart layer tiles. Currently, it's a very simple approach with a 3x3 pattern. So 9 tiles in total around the car itself. And what we use to test the client side is we take a track file, which we replay. So it contains GNSS positions. We take into our electronic horizon provider, where we perform some map matching some caching of the data, and calculation of a most probable path, and then makes the data available using a DASIS version 3 standard. And we have this separated, as you can see here. So there's some TCP connection between two different applications. And on the right side, we use what's called EBAssist ADTF. It's a framework for recording and replaying data in a very accurate, timely fashion. And here we employ an eHorizon reconstructor and then go with a scene display and an explorer for the data. So we validate really from end to end using GNSS input. On the one hand, the cloud with the NDS.Live information on the other hand, and then create really like it would be done in a car and distribute it. So let me briefly show our experience. So in the first batch, in the first video, you can see the demonstration from here. Yeah, so we have multiple filters connected to it. This on the left side is where we get the TCP information. So that's already the DASIS version 3 electronic horizon. And on the left side, you can see a very simple display of the driving scene. Yeah, so you can see, okay, there's multiple roads shown. Yeah, so this is roads. What you see on the left. On the right side, you can see the Explorer showing the different profiles which have been generated out of the NDS.Live tile content, and it's in offsets upwards. Yeah, so in distance, currently we're driving around 50 kilometers an hour, driving on the A81 towards Lake Constance, and you can see on the right side, okay, what we fetch from the backend. Currently, it's a simple lane model, so there's just a total number of one lane. But you can see already a road geometry as a polyline with now it's increasing depending on the area where we are. So we drive along, and you can see quite a number of different points on the polyline as a road geometry. So what we currently fetch is of course the lane layer and the lane geometry layer, and we can highlight the parts which are included in the tile information. Yeah. Also, you can see on the left side of the Explorer, marked in red, a car position. That's the output of the map matching itself. Yeah, so the best guess where the car is currently located. And yeah, for the here backend, we currently were able to fetch most of the road geometry and the lane connectivity. Of course, we tested it also with Navinfo backend. Yeah, so you can see it's a very same configuration. So in our tooling, it's merely changing the authentication towards the backend and the uniform resource locator, obviously, to connect. But you can see, okay, it's pretty similar from how it looks in the display. We also can generate a lot of profiles. But now on the right side, you can see, okay, apart from the road geometry, we also were able to get the lane geometry and different objects like the center line. So some information is still missing. We decode the center line geometry layer and the different lane groups. But yeah, still, of course, there is room to extend. But as the backends are just coming up and getting ready, I think this is already quite some progress to make it available end to end, really in a fashion how it would be deployed to a vehicle. Yeah. Okay, for TomTom, yeah, we did likewise. We had some trouble last week to really fetch the data live from the backend. So we used the LabVIEW tooling to fetch and download the tile up front. But still we can replay it, and all information looks sound and according to the standard. Yeah, again, we have different profiles and a fixing from the map matcher based on the track file and the electronic horizon reconstructed. So next steps on our side, yeah, are of course the map streaming by paths and objects. I guess NNG will show later on also more on the path part, not fetching it tile by tile, yeah, but rather by path. And of course, the map attributes, there's more to fetch from the backend and more to bring into ADASYS version 3. And coming also up is, of course, special attributes, for example, for trucks, or with a focus on ISA. So that's our current status on getting things ready on the client side. And now I would like to hand over.
Thank you, Dirk.
To Frank. Yeah.
Yeah. So Frank is next.
Hello, everyone. Will you share, Fabian, or should I?
I think we said you wanted to share.
Okay, all right. 1 second. So, okay, can you see my slides?
Yes, but we still see the editing view. So you know, maybe the wrong view has been shared. Maybe it works if you click on that one.
How about now?
No, we still see that. So
okay.
We have to restart the share in Zoom.
Yeah, all right.
First, start the presentation and then.
Yes, all right. So 1 second.
If that doesn't work, I can also, yeah,
so,
no, perfect.
Now you should see it. All right. Computers, who understands them? Okay, all right. Hi, hello, everyone. My name is Frank Aurich. I'm a software engineer at Joynext. And today I would like to show you our implementation of an NDS Live routing service. I will start with a short recap about what we did with NDS Live so far. And I will present the goals we set ourselves for the routing service project here. I will then talk about the implementation. And last but not least, I would like to give you a little live demo. Okay. At the last NDS Live conference, we presented our visualization client rendering NDS Live road data. Since then, we've added support for the road characteristics and rules modules, allowing us to process additional attributes like functional road classes, which you can see here in the screenshot as different line colors, as well as other attributes like speed limits. We've also added support for rendering lane geometry and processing lane attributes. For this conference, we set ourselves 2 goals. The first, to develop a route calculation service for NDS Live based on our existing route calculation engine for NDS Classic, and also develop a route calculation client which then visualizes the route. And this one should support both NDS Classic and NDS Live Map on client side. Since NNG also developed a routing service and kindly offered us access to it, we added a third bonus goal to see if our client also works with third-party clients. And I will present this later on. All right, so what is the routing service? The routing service is a lightweight interface for route calculation that is map independent, which means the client and the route calculation backend do not necessarily have to use the same map. They actually don't even have to use the same map technology. In its simplest form, the input is just 2 coordinates for start and destination. And if you want, you can optionally add some stopover coordinates or define some route options. The response or the output from the routing service is a description of the route using indirect feature references like location geometry, segment bearings, and decision points. It is the task of the client to map match these references onto the underlying map. A few words about the implementation. The server application is just a wrapper around our existing route calculation engine for NDS Classic data. It is written in C++ and uses HTTP REST to communicate with the clients. The client application is just a plugin for our existing NDS viewer, which is written in .NET. It implements the communication with the server as well as the map matching heuristics for both NDS Classic and NDS Live Map data. In our current implementation, we only evaluate the route reference points for map matching. So we will experience some map matching errors here and there, and I will show you this in the demonstration. All right, so much for the theory. Let's switch to the live demo. Can you see the demonstration now?
Yes.
All right. So here we have, in our first scenario of the 3 scenarios I want to show you, we have an NDS Classic map. This is our lovely city of Dresden. And we are connected to our own routing service, which is also using an NDS Classic map as backend. So what we can do is we can simply define some start and destination points. Let's go from here to here, and then let it calculate the route. And in a short time, well, this is a very short route, it renders the route onto the map. If we enable the route reference points, we can see all the data that has been delivered back by the routing service. And if you also enable the map matched route intersections and zoom in a bit, you can see that basically every intersection matched onto a route reference point. And this created this route. Yeah. So this is NDS Classic on NDS Classic using an NDS Live routing service as intermediate. In my second scenario, we want to switch to an NDS Live Map. We have here an NDS Live Map using a road smart layer kindly provided by Navinfo. It uses OpenStreetMap data and should therefore be a bit different from the commercial map in the previous demonstration. We have a different location here, mainly because this service doesn't have the data for Dresden right now. And again, let's set our coordinates. We'll start here, we'll go to here, and calculate. And again, we see the route is being calculated as expected. If we now have a look at the route reference point and the locations, we can see that there are now indeed differences. Here, the routing server has a slightly different location for the intersection than the map on client side, but we were still able to match the intersection. But if you go below here, you can see there are reference points from the server sent that do not match an intersection on this side. These may be able to be optimized out of the routing response at a later point. All right. And finally, our third scenario. In this scenario, again, we have the smart layer of road service from Navinfo. And now we switched to the routing service from NNG, which is the third party. And the display has been done by our client. And if I want to set some coordinates again, let's go from here to here and calculate. Again, the route is being calculated. I chose this example specifically to show you that we are now experiencing some map matching errors here. As you can see here, the routing decided to go over this lower class road instead of following the main road. This is basically a bug in our map matching, which has yet to be fixed. And there's another bug on this side where it decided to go on this link, which is probably not even allowed due to turn restrictions. Should have chosen this link instead. These are issues that have still to be fixed. And I am sure that once we incorporate all the data that is provided by the routing service and improve our map matching heuristics, then we will get perfect matches for the routing here as well. All right, that's already it. Thank you for watching and bye.
Okay, thank you, Frank. So next, last but not least, is Otto Nero from NNG.
Okay, I hope you can see it. You can see my screen.
Yes.
Great.
Your screen and your car.
That's the dream of, yes, the dream car. Okay, so hi everyone. My name is Otto Nero and I'm leading the NDS Competence Center at NNG. As a member of the NDS Live Dev team, we have been working on ISA and ADAS use cases with special focus on Horizon Assist, that is an NDS Live application service for map matching and horizon generation in the cloud, and Smart Layer Path service for streaming the road ahead in a unique way. So during the last couple of months, we have been working on two different map provisioning approaches for ISA and ADAS applications that NDS Live enables. The first one is utilizing the Smart Layer Path service, where the full tiles are streamed to the client and consumed by an onboard electronic horizon provider. While the second one streams only the map path to the client. In this case, the horizon calculation logic needs to be offloaded to the cloud. Both solutions are simple, as we don't need any pre-installed map on board. Everything is requested and streamed on demand. However, there is one fundamental difference between the two approaches based on where the horizon is generated. The left one is the, let's say, the commonly used approach with onboard e-horizon provider, while the right one is the more cloud-centric, and it can reduce data consumption significantly as well. So let's start with the Smart Layer service. When the first DPI signal is received and online connection is available, the client requests Smart Layer tile around the car position. Only the road layers and the speed limit attributes are streamed, that is required for ISA. The speed limit signs on the screen are rendered based on the cache data. When the tile is downloaded, it is used for onboard map matching, so that the speed limit info at the car position can be easily detected. While the car is moving, the system can calculate the most probable path based on the map tile. It will trigger additional tile streaming on the for the horizon. When the car is approaching the tile border, the next tile is being downloaded automatically and cached for continuous map matching and horizon generation. When speed limit warning is speed limit warning is displayed according to the cache data. So you can see that we also switched the speed limit warning on the video. In the download counter, you can see the accumulated data consumption while streaming the tiles in the corridor. So let's see the interoperability. So with NDS Live, it has never been so easy to integrate any third-party tile streaming services because it was designed with the interoperability in mind. To prove it, we have integrated the smart layer tile services offered by here, Navinfo, and TomTom. All we had to do was just changing the URL link of the service and its authentication, and it works. For NNG, this is one of the key benefits of NDS Live. I use the same route to generate the horizon and simulate fetching the smart layer tiles from different services. Due to service interoperability, the NDS Live client is compatible with all services. Another benefit of NDS Live is that it enables supporting advanced map streaming use cases as well. For example, why shall we download the whole tile if only a tiny part of it is used, especially when it comes to ISA, when only the speed limit information is required? In NDS Live, it is possible to fetch only the pass with the speed limit info. And comparing the required data consumption for a tile and the pass, the difference is huge. The pass is almost 20 times smaller. It can also minimize the data consumption for ISA. So let's see how this smart layer pass looks like. When the car starts moving, a tiny map pass is streamed for the horizon, along with the adjacent roads. It's quite similar how the e-horizon provider generates the map horizon for the road ahead. But in this case, we don't have any map on board for calculating the most crowded pass. It is only possible if the horizon is generated in the cloud. So the client application provides the car position and the heading information to the horizon assist for map matching and generating the horizon in the cloud. Then this horizon is used for fetching the map from the smart layer pass service by filtering only the required road segments. Not just the pass, but also the adjacent roads are fetched. These are called stubs, and they are selected topologically and not spatially. It means that prohibited turns are excluded while fetching the adjacent roads. For example, where no U-turn is possible, the road segments on the opposite directions, on the opposite direction is missing from the filtering. Now let's make a comparison between the smart layer tiles on the left and the smart layer pass on the right, while streaming the map for the horizon. The most obvious difference is the size of the downloaded map data. With smart layer pass, we can save up to 90% on data consumption compared to streaming full tiles. With this solution, we can provide always the latest speed limit info, but with minimal data consumption. You may wonder why the stubs are required to be streamed along with the pass. So let's see a comparison with different settings while fetching the stubs. On the left, only the pass is streamed, no adjacent roads. In the middle, the stubs are selected based on a 50-meter threshold. On the right, a wider corridor is fetched with 150-meter long stubs. Streaming the adjacent roads is essential for onboard map matching, especially when deviating from the pass. They can help to indicate when a new pass needs to be requested and bridge also the response time until the new pass is fetched and streamed. So this is exactly the case that you've seen on the video right now. Without stubs, we cannot match. So we need to request a completely new pass. And furthermore, these stubs can also have the ISA fusion modules when the camera detects speed limits on the adjacent roads. Maybe you wonder why, what kind of caching strategy can be applied for smart layer paths. And you are right. Compared to the normal type caching, it was absolutely not straightforward how the paths can be cached in an optimal way. And this is not just about the onboard caching, but also in the cloud, to make this cloud-centric solution cost-efficient. Finding the right caching strategy is key to make this solution viable. At this point, I would only like to talk about a few ideas, how it is working currently. After some development iterations, we concluded that fetching and caching the paths as type-based seems the optimal way. It is also possible to persist multiple independent paths in a tile, as you can see it on the screenshot. Whenever a path is cached, both onboard and in the cloud, it can be reused to save cost. It is also possible to combine tile and path caching onboard, like a home area that can be covered by cached tiles, while outside of the home area, only the paths are cached. Data plan is one of the most frequently asked questions. How much data plan is required for this solution on a monthly basis? So let's see two examples, regular commuting route and a long business route. For the daily commute, I selected 30-kilometer long routes in suburban urban areas and simulated them in both directions with several deviations from the path. The average data usage for such a commuting route is only 110 kilobytes. Then I simulated a 200-kilometer long interurban business routes in both directions, and the data usage was only slightly higher compared to the daily commute route. The estimated monthly data usage is less than 5 megabytes, but it also depends on the map update frequency of the smart layer data, like it's quarterly, monthly, or weekly. So when implementing a standard, it is important to test the interoperability capabilities of the solution. So we tested the smart layer path solution with different smart layers provided by here, Navinfo, and TomTom. We made a proxy server for fetching the smart layer tiles from the service providers. Then we deployed our Horizon Assist and smart layer path service also there. As a result, without changing anything on the client or in the interfaces, we could easily switch between the smart layer providers on the server and test the interoperability of our solution. NDS Live supports the functionality of requesting a list of tiles and using them for pre-caching. Based on this function, a list of paths can be also streamed. The length of the paths and the adjacent roads is scalable. This use case can be used in rural areas with poor connectivity. Due to small data size, pre-caching along the path is still feasible, even with limited bandwidth. This long horizon path can help to bridge connectivity blind zones as well. When deviating from the calculated path, a new or a long horizon is generated in the cloud, and a list of paths is streamed for the new horizon. And this is the exact opposite of the previous example. And actually, this is my favorite use case. So with NDS Live, it is also possible to shorten the length of the path. In this special case, only a 250-meter long path is streamed for the horizon. Unlike the normal path, This approach is fully independent from the tiles. However, it requires more requests, so it may be applicable only in urban areas with dense road network and good connectivity. Now let's compare these two different solutions. On the left-hand side, the normal path is streamed as time-based. This solution is optimal for caching the paths in the cloud as well as on board, by keeping the number of requests low. In contrast to the normal path streaming, the data consumption of the short path streaming on the right can be slightly higher due to more requests. And the optimal caching of this kind of short horizon path is a little challenging as well. But it can be used for fetching real live data with momentary validity, like variable speed limits, which shouldn't be cached. Or maybe we can think about this approach for live HD lanes. With this use case, I just wanted to demonstrate the flexibility of NDS Live, that even this unique approach is possible with NDS Live smart layers. And finally, I did some field tests to validate the solution while driving. The tiny client application was ported onto Android and installed on a tablet, while the Horizon Assist and the Smart Layer Path service was running in the cloud. For the field test, I used the built-in ISA function of the car as a reference, so I could compare the results. I was curious how the online Horizon Assist works under real conditions, and how the path is retrieved from the server matches the horizon of my driving path. I also tested the latency of the service when deviating from the path. So I took this random left turn, and the new path was streamed instantly. This is because the stubs plays an important role for map matching and for indicating when the new path shall be fetched. And this is the last video. So I tested the short path streaming as well. And for that, I used the extreme settings. Only 100-meter long horizon was requested while driving on the same road. So I could see on the screen how the short horizon of the smart layer path is streamed for the road ahead. Then I took the same left turn to see what happens if I deviate from the generated short path. Unlike in the previous video, it behaves differently at deviation, as the short path is streamed with some delay, because it does not immediately request the new horizon, only when approaching the end of the stub. We will still working on this solution by further optimizing the number of requests and its data consumption. But it's good to see that NDS Live enables even such a unique use cases as well. So thank you for your attention. And now let me give back to Fabian for the QA session.
Yeah, thanks, Otto. Thanks very much also for the nice videos. And now we have time for some questions from the group. We already have 2 questions I would like to start with, but I would also like to encourage all the others in the audience to still type the questions. So maybe we'll start with one for you, Otto, right away, which is, how does the without stub not detect the opposite direction of the road? Wouldn't it still be quite close to the vehicle? So I think that was referring to these 3 combinations you showed.
Yeah, so I also tested this special edge case on field when no stubs was fetched, and so for the onboard map matching, it's a nightmare. So fetching and streaming on the path only without adjacent roads, it's not viable for this kind of use case. But the path without stubs can be used for fetching only certain layers, let's say speed limit layers, where we don't need the adjacent roads. So there are some use cases where it makes sense to let's say unfilter any adjacent roads. But yeah, so it's quite an extreme use case indeed.
Okay, thanks. Then there is another question, which is NDS based on Openlr? No, but it kind of like uses the, so I'll take that question right away. It's not based, but it uses, so for the map matching part, it uses similar concepts. So let's put it like this, very similar concept. So it's not really completely based on Openlr, we're not reusing that, but the concepts are, the underlying concepts are the same. And they are extended by NDS because basically we have even more information because it's not format agnostic like Openlr tries to be. So we can say, hey, we have this information in the format. We can take a variety of other things. I think Frank mentioned those, the additional attributes you can use for a better map matching and so on and so forth. Good. Then there is another question. How do you foresee the coexistence of NDS Live and ADASIS in the car as means of sharing map information? I don't know who wants to answer this in this round. Maybe since Dirk, you did talk about or ADASIS or showed an ADASIS electronic horizon, maybe you want to take up this question.
Double mute.
You were on mute and you, yeah, and
is it working now?
Now we can hear you, yeah. And maybe turn on your video again as well. That would be great.
Yes. Now it shows up.
Yeah, perfect.
Yes. So yes, of course, there we expect a coexistence. Yeah? I think it's complementary. Yeah, where on the one side you maybe would use the NDS.Live standard to actually retrieve the data from the backend. There's still the question how to distribute it and how to also computationally distribute it efficiently and only provide those attributes relevant to the specific ECUs. So yes, it makes sense to use both.
Okay.
Hope that answers the question somehow.
I hope that too. Good, thank you. So there's another one on which came in very early. For NDS Live client-server communication, all layers need to be aligned and described in NDS Live APIs, layers, attributes, protocols. What I got there are plenty of options provided today. First question is, will there be some recommendations for protocols, at least for the back end and vehicle communication? So that was probably related to how I explained that it's basically not tied to any of the protocols. But the question is, will there be a recommendation? So I would say probably from an NDS Association point of view, there will not be one recommendation to answer that, but we would probably see where the market goes, right? So it will potentially, I think everybody is using some kind of HTTP REST APIs or whatever today, but that may also change in the future. So I guess this will be done. So I don't know, maybe guys, you can correct me if I'm wrong. But my take on this is that basically the market will simply steer that, and this is basically why we did it, right? So that we can follow the market and we don't have to set something in NDS in stone. And after 10 years, you say, "Whoa, that's old. Why do we still need to use this transport protocol?"
I guess HTTP and REST, it's a very common protocol. So maybe it's not the single recommended one, but should be good for most cases, yeah, I guess.
Okay, and then there's another one which says, will there be recommendations which Zoom levels to support initially for the IVI use case? I guess that's probably the same. There will be no direct recommendations from NDS on this. Good. Let's see. I'm not sure if we are still on time, if we can take another question or two, maybe one last question. The last one doesn't sound like a question, so I'll take up the how can the Live Lab tool be accessed? I think Uli Otto already also gave a similar answer before. So that's basically available to all NDS members and can be downloaded from the NDS servers. So this is how you get to the Live Lab tool. Good. And if there are no more questions, I'd like to thank all the participants, especially the speakers. Thanks for having been with us today. And
thank you for watching. Visit our website for news on NDS at nds-association.org.